This is a lesson summary video for the task titled Data Distribution. This is a solidify and practice understanding task. The purpose of this lesson is for students to describe data and compare two or more data sets. In this lesson, it starts off with discussing some vocabulary and talking about what you're doing when you are actually describing a data distribution. So when you're describing a data distribution, you're talking about the shape, the center, and the spread. So with the shape and the spread, it starts off with explaining about modes. So remember, a mode is the number that appears most often. So if your data is evenly spread out, then it's considered uniform. It has one peak. So if you're looking at the histogram and it has one peak, it's unimodal. Bimodal has two peaks, or multimodal has multiple locations where the data is relatively higher, so multiple peaks. So then we have a skewed distribution. So when most of your data is to one side, leaves the other side with a tail, the data is skewed to the side of the tail. So normal distribution happens when the data is symmetric and unimodal. So outliers are those extreme data values that are away from most of the data, the body of the distribution. And what we do to check to see if there's an outlier is we use the 1.5 times the interquartile range to see if the data value is more than 1.5 times the interquartile range beyond quartiles 1 and 3. So variability, that's talking about how spread apart the data values are from each other. So if there is a high variability, then that means that the data values are really spread apart, and low variability means that the data values are relatively close together. So then with the center, it's talking about the mean or the median. And what this is saying is that it's nice when you have a normal distribution, everything is nice and symmetric. The mean and the median would align. But if it's not symmetric, meaning that it's skewed to the left or skewed to the right, then the median might be a more appropriate statistic to describe the center. And also it points out that bimodal or multimodal data may not have a center that would provide useful data. So we're going to look at an example of comparing three different data sets. These are quiz scores from two different classes and then the overall achievement data. So we have Anderson, who is a teacher, Jones, who is a teacher, and their quiz scores for their classes. And these two classes, plus a few other classes, have their data combined for the overall test achievement data. Let's start with Anderson, and we're starting with the shape. So Anderson's data is unimodal because it has one peak, and we can describe it as a normal distribution because it is fairly symmetric. If we look closely, since the frequencies are listed here, we can see that there are 8 quiz scores over here to the left of the peak, and there are 8 quiz scores over here to the right of the peak. And even though it's not perfectly symmetric, that is pretty close to being really symmetric. When you collect data in real life, it would be very rare to have a perfectly symmetric data set, but we're going to describe this as unimodal and normal. Jones's data is unimodal because it has its one peak, and it is skewed to the left. Skewed to the left, remember, is showing us that we have most of our data over here to the right, but we do have this tail end over here to the left, so we say that it is skewed to the left. In the box plot, we can tell that this is skewed to the left because if we look at the length of these two whiskers in this box and whisker plot, the distance from 40 to 71 is greater than the distance from 79 to 100. So we can see that we have this tail end over here, these data values over here to the left that are changing this shape from looking completely symmetric. So we have a long tail to the left, so it is skewed to the left. So now let's look at measures of center. So for Anderson's data, we have a normal distribution. So that means the mean and the median are approximately the same value, which would happen right at the center of the histogram. This bin, this column, is representing scores between 80 and 84. So the mean and median would be somewhere between 80 and 84. All right, for Jones's data, we know that the median is somewhere between 80 and 88. And I know that because if I count my frequencies, I have 1 quiz score here plus 2, that's 3 quiz scores, 6 quiz scores, 10 quiz scores. So there's 10 quiz scores over here. that are less than 80, and I have 11 quiz scores that are greater than 88. So in the middle, these 5, the median is somewhere between 80 and 87. So that's where the median is. And since this data is skewed to the left, that means we have these low extreme values that are pulling the mean left, which means that the mean would be lower than the median. So I could approximate that it would be probably somewhere between 72 and 80, but I know with confidence that it is definitely lower than the median. And in the same way for this box plot, the median is really easy to see because it is the second quartile right there in the middle of the box. And because we determined that this distribution is skewed to the left, we know that the mean would be to the left or lower than the median. For measures of spread, if we take a look at Anderson's data, I'm just looking at the range here. And again, I don't know exactly what the range is because all that I know is that we have 2 values between 65 and 69, and there's 1 value that's between 95 and 99. So that can give me an approximation. For Jones's data, I can tell that the quiz scores are more spread out. For the box plot here, I can get the actual range because I have the maximum and minimum values. So I know that the range is 60. And the interquartile range, I can also get that. I know that that's 8 because I looked at the width of the box here. So all that I can really tell is that Anderson's data, it varies less than Jones's class data and the overall data. So I can tell that it is clustered closer together when compared to these other 2. All right, that's it for this video. Thank you for watching.